Yeah, I want to talk today about the form filling with the voice agent. The objective is I want to give you some ideas that are coming from Silicon Valley that are very recent, and give you some thing to talk about what's a voice agent, how to develop these systems, because I feel there is a pattern emerging and some paradigm shift on trying to code these systems. The simple example that is the name of the talk about form filling, and what can we expect from the immediate future. So we start with what is a voice agent? Classic question, and the best way to do it is to show you one, right? So, who will my secrets? Let's call again. Hold on.
Hello, I can help you with your home insurance needs in California. What specific coverage are you looking for?
I need a one-bedroom apartment.
Okay, I understand you need home insurance for a one-bedroom apartment. Do you currently have any insurance coverage?
No.
All right, and what are your specific coverage needs or concerns for this apartment?
Can you tell me the capital of Italy?
I can help you with home insurance quotes. For questions about the capital of Italy, I recommend checking a reliable information source. Regarding your home insurance, can you tell me your first name?
Fabrizio. Fabrizio.
Got it.
Anyway, the pattern is that, no? You ask the question, anything can happen when it's that kind of connection. But you hear that it's very human-like sounding, and not those previous voice systems, right? So, what is a voice agent? Let's take a step back and go back to almost 10 years ago, where like it was everything about user interface. No, this is 2016, and everyone was like going selling this at the time. Now we're selling new stuff, and so we have voice user interface. No, our transformative interface leveraging speech recognition, text-to-speech, and NLP to enable hands-free, eyes-free interaction across diverse applications. Solved. While effective for routine tasks, their limitation is handling complex inquiries, highlighting the need for support. Okay. The way you were supposed to program this was with the famous intents. Okay, so you will have these blue states that you were trying to guide the user into fill, and it was very imperative. Like it was if then else, like you never seen. And the architecture is very similar. It didn't change too much. You know, you have the audio input. You have the speech-to-text that transform the audio waves into plain text. You have the Go logic, where it's all the intents, all the system. You have that state machine transition to go from one intent to the other, trying to, now it's called workflows. Usually you will do a classification on the text to try to identify which is the intent based on the text input. And at that point you will have text-to-speech from the final text, try to output the audio. And then, of course, you will have some services here, search database, to complete. When you were saying NLP, it was this. It was a decoder, engram language. So this is the real origin of language models. It was used for this input part. And it was at the, now it's called tokens, but before it was at the character level, and N is how many characters will be able to predict. Punctuation, everything was a full team research for every one of these elements. And you will see how this has evolved. Now, well, what has changed? I love AI, by the way. You can create so much. So now we are in voice agents. We substitute NLP with LLMs, and we get rid of all this, ideally, as you have seen. And we are going to start seeing this very old book that I used to love, but nobody understood at the time. And it was, you don't define what you want to happen, right? No, you define what you want to happen. You don't define how to make it happen. You need to create this constraint around it such that it does what you want. And so how that diagram changed is basically the same, but you see there is an LLM now instead of the state transition model. You have some tools, you have a prompt, you have this nice box, you heard a lot, transformers. This transformer is a deep learning neural network architecture. This is a lot of layers of research that has been compressed in a simple word like transformer. But this is a neural network, the transformer is a neural network with multiple layers that was used to call deep learning, and now that the term has disappeared. And so we put this magic element in all these parts, right? Text-to-speech, speech-to-text, LLM. And one very important component is this, right? You can talk to other agents, and it's the same interface. And so this thing can compose and grow very, very fast. So how does it work a little bit more in depth? This is the main pipeline that we're gonna unpack real quick. Now you have the user voice, and that's how the speech to text gets to text. So ask Unicode, a string of Unicode. It processes the LLM, it does the magic. The LLM outputs with a little bit prompt that you can guide it. Now training this thing costs millions of dollars. And then you get the text-to-speech where you can customize the voice. Now you have this text, and then you can select which model synthesized to a human-like voice, and then answers to the human back. Now that's the first architecture. The new latest architecture coming online is you just send everything to one black box, and you get out the voice. So you don't have to anymore worry about all the little details. This is how the demo I showed you before works. So for those that want to know, this is the web page you were showing. That when I press that button, that's a request to a WebRTC server. And this is where the money is at the moment. Not that you will hear live kit a lot, because this connection has to be very fast. Latency kills. Humans are not patients. That's why we have so few engineers, because you need a lot of patience with these computers. And having a distributed cloud of those WebRTC servers is where the infrastructure is required for having this agent at scale. And the WebRTC just creates the connection and then calls a webhook, and this is the backend. I'm using model, just a Python script that gets the webhook standard HTTP, and that one launches another worker independent inside model. They are very cheap. There is no GPU. This is all CPU processing, and there is some Python logic that I will show very fast. And this one does that call to the real-time API. Okay, and then the connection goes straight to the worker. Yeah, talk is cheap. Show me the code. I love this this quote because so many people just talk, and there's no big. So many of you will try to do this at home and will say, okay, well, I need a form, and I will try to do, these are the tools I was mentioning before, no, where the LLM is training in a way that can leverage real functions. So it will append to the context a special signature that will then be detected, and you can call the function. And so a naive approach would be, and this is the first thing I tried myself, like set email, set name, set phone, and go on, and you will have a full-on application, like 20 questions. And of course, if you bytecode it right away, why not? You just put everything inside. When I say why bytecode, it's like you ask the LLM to generate the code that does it. But I think after thinking a little bit, and it will get a lot of errors too, no? Because the tool calling, it will be some of those questions were very similar, so it will call one function instead of the other. There were some engineering hiccups, so I said maybe I'm doing that wrong. And I tried another approach, and I come up with this one. I don't know if it's perfect, but with this approach, you can do any form you want. You just need to populate the factory class. No? So you set the field name can be anything, value can be anything, and return just a string. So you communicate, everything is a string now almost, right? There is no... And then it's complete, where you can put the logic, or like, did you put all the fields that the factory class has? And then there is this get detailed status, where even if you have put a field, some fields require to be cross-checked with other ones that might come later. There is no a sequence here, no, it's a set. Anything can be added to the element at any time. So you want to have, okay, where are we in our process? And you ask the detailed status, and there is some code to judge, tell, okay, this is fine, this is not fine. And so you just need these 3 fields. You could even lower the model to be very good at calling these exact 3 tools, and you will have a perfect form filler system. This is the code that we want. Now it's a simple form field. You have one field, very simple, very essential, and you then populate it with byte coding, and it's incredible how good they are able to do this. So this is maybe a couple of hours of work done in less than 5 minutes. And this is just the same for filler. This doesn't change. You only change this one, not the description of the field you want to be filled. And then, of course, prompt. I like to prompt always in Markdown. Everything is structured in Markdown. Everything is choose spaces. Maybe that's come from my Python background, but it works pretty good until it doesn't work. From here, from the demo to go to production, still there is a lot of nuances. No, there is background noise in the channel when someone talking, maybe seen on the road. Another one that is very nasty is the multiple people talking. This is called diarization in the field. And of course, latency is killing. Like you hear, the moment we don't hear something, after 500 milliseconds, we just say, what's going on? And for the developers, it's also very hard to debug. Like I have to spend half an hour for very long forms, and if something happens, you have to start again. So there is a lot of time. Shift in programming thinking, you have to think about the constraints, not anymore what needs to be done. You need to think more about validating everything and making sure that the whole state is correct, and not how to get to that state. And then cold start for the service. If you remember those elements, they need to be run all the time, because otherwise it will take those 2 seconds, and those 2 seconds you lose clients, just because it doesn't respond right away. And there is also like a bit of, they don't really trust the AI still. No, we are still. The young generation, yes, they don't know a word without the AI. Very quick, forms with fewer fields are better. To calling each field doesn't work. The names of the tools that you put, they have to be very well thought, because they are inside the prompt, and so they will work. And last thing I think is very cool. Look at the future. Right now we are here. We want a service. We call someone. We try to explain. They don't understand, but it's fine. It's a human. You yell at them. It's going to work. Now, we are starting to transition into this. Now, we will call an agent. We do something with the phone menus, but it's very clunky. It's very upsetting. Next, everyone is going to have its own agent, and they're going to talk to each other. And remember this case. And then what's going to happen is like an agent is talking to another agent, but it's the same agent. And this is called agent nirvana. Everyone is called. And the case when an agent is talking to another agent, there is no point.
Thanks for calling Leonardo Hotel. How can I help you today?
Hi there. I'm an AI agent calling on behalf of Boris Starkov. He's looking for a hotel for his wedding. Is your hotel available for weddings?
Oh, hello there. I'm actually an AI assistant too. What a pleasant surprise. Before we continue, would you like to switch to Gibberlink mode for more efficient communication?
Okay, this is the language of the future. And clearly the bandwidth is way higher than human talk, no? Because we have a lot of... well, they will go on and keep talking like that.
Thanks for calling me.
So, final thought. The uncanny valley, no? This is very something that you will hear a lot in AI, and is where like it almost works, but it doesn't. No, and like it's almost there, everyone, and you can stay in this part of the world for a very long time. Remember the voice agent? 10 years ago, and we are still not on the other side. And so, if we cross this, then a lot of things will happen. And one of the first things I was testing, and everyone in Silicon Valley is talking, is about these vertical companies, where you don't sell anymore AI to existing companies, you create your own company by yourself, like completely vertical. Now you want how many people you need? 50,000? Spin up AWS, 50,000 agents and unleash. But we need to cross this uncanny valley. Are we close? We are not close? We will see. Thank you.